Okay, looking at the next page, it says remove the bool. So it says sometimes expressions might appear equivalent, but they may not be exact. So how can you tell for sure? So what I'm going to do, I'm going to work the left-hand side, that column, and you guys are going to do the right-hand side. So if I look at my y equals, I have in y1, 1 divided by x plus 2. In my y2, I have x over x squared plus 2x. So it show that the two functions above are equivalent by factoring and simplifying y2. So for y2, I have x over x squared plus 2x. Now in my denominator, I can factor out an x. So I have x parenthesis x plus 2 left, and the x stays in my numerator. Now remember, if I have it in top and bottom, I can cancel. So what I'm left with is 1 over x plus 2, which is the exact same thing as y1. So let's generate the table. So in my calculator, I'm going to go in y1. I'm going to type in 1 divided by x plus 2. And in y2, I'm going to type in parentheses, x divided by x squared plus 2x. Okay, and I'm going to go to the table. So what it asks me to fill out is all the way from -2 to +2. So if we look, we have an error for both of them on -2. We have a 1 for both of them on -1. Now what do you notice about 0? You should notice that one of them is 0.5 and my y2 is an error. And then 1, 2, 3, and 4 are all, again, the same digit. So I want you to go ahead and fill out that table. So it says, in what way are the tables not equivalent? So again, the table for y2 had an error at 0. Okay, and from here, I just want you to sketch the graph. So in my calculator, I'm just going to hit graph. And it just asked me to graph y2. So you're going to graph that first graph right there. Okay, so let's look at the last question. It says, how many vertical asymptotes does it have, and does this match the information on the table above? So remember, for a vertical asymptote, it's where we see error in our calculator on the table. So here I do have a vertical asymptote at x equals -2, but I know we see another error at 0. So here's what I want you guys to do. You're going to work 4, 5, and 6 on the right-hand side and turn to the last page. Okay, so here it says, usually the values of x that make the denominator equal to 0 will create a vertical asymptote. Remember, on the last assignment I had y'all set the denominator equal to 0 and solve. So it says, unless that value makes the numerator equal to 0 also, then this is going to create what's called a removable discontinuity. So let's look at our example. We have f of x, which remember is the same thing as y, is equal to x squared minus 3x divided by x squared minus 2x minus 3. So it says we're going to factor both the numerator and the denominator. So your first step is going to be to factor. So when I factor my numerator, I can take out an x. So here, when I take out the x, I have x parenthesis x minus 3. In my denominator, using either SPT or I can factor using my head, I've got x plus 1 and x minus 3. Okay, so from here, my x minus 3's are going to cancel. So here it says if you plug in an x value and get a number over 0, the graph will have a vertical asymptote. But if you plug in an x value and get 0 over 0, then the graph will have a removable discontinuity. So it says for these functions, factor the numerators and the denominators to determine where any horizontal asymptote, vertical asymptote, and removable discontinuities occur, and check by graphing. So I'm going to work problem number 1, and you guys are going to work the rest. So let's look at problem 1. All right, for problem number 1, I have y equals x squared plus 6x plus 8 divided by x squared minus x minus 6. So remember, our first step is to factor. So I'm going to have y equals, and in my numerator, remember I have x and x to make x squared. And what two numbers can I multiply together to give me 8 that will add to give me 6? Should be a positive 4 and a positive 2. Okay, then I might have divided by, I'm going to factor out my denominator. Again, x and x. And what can I multiply together to give me a negative 6 that will add to give me a negative 1? So I should have a negative 3 and a positive 2. Okay, now, in order to answer for my horizontal asymptote, remember we just went over those rules, so if you need to look back on the first page, look at your rules. Here we're looking at our exponents, so we're looking at our degrees. Here I have a degree of 2 in both the numerator and the denominator. So if my degrees are the same, I do the coefficients. So here, both of my coefficients, even though there are no numbers, we know they're 1. So here, my horizontal asymptote is at y equals 1. Now my vertical asymptote, or actually let's do removable discontinuity first. Whenever I do a removable discontinuity, it's going to be based on what I actually can cancel out of from factoring. So here, remember if I have an x plus 2 on the top and the bottom, those both cancel. So all I have to do is change the sign. So if I have x plus 2, I know my answer is going to be x equals negative 2. That should be a 2. Okay, and now what I have left, remember yesterday I taught y'all to set the denominator equal to 0 and solve for a vertical asymptote. So I have x minus 3. I'm going to set it equal to 0. So when I add 3 to both sides, I'm going to have x equals 3 as my vertical asymptote. Okay, so what I would like for y'all to do tomorrow in class, you're going to finish the rest of this packet.